Welcome to MyProjectBazaar.com. Our project title is Distributed Progressive Algorithm for Maximizing Lifetime Vector in Wireless Sensor Networks. Abstract. It is important to extend the network lifetime in order to achieve the better transition in wireless sensor network. However, when one node dies, the rest of the network can still work as long as useful data generated by other sensors can reach the sink. In earlier days, centralized algorithm resolves a series of linear programming problems with high order complexities. A fully distributed progressive algorithm which iteratively produces a series of lifetime vectors, each better than the previous one. Simulation results demonstrate that the algorithm is able to converge rapidly towards the maximum lifetime vector with low overhead. Let us see the flow of our project. First, network is forming. After deploying all the nodes, we have to maximize the lifetime vector based on our path identification. If it is validated, we have to schedule the packet using distributed progressive algorithm, and from using this distributed progressive algorithm, we have to identify that which are all the sleeping nodes and which are all the active nodes. So the information, there is a data packet is sent via only the active nodes. Then data transmission is done via that nodes, and the evaluation process is done based upon four parameters such as packet delivery ratio, energy, throughput, and delay. Let us see the output of our project. First, open the terminal window. Before running our project, first ensure that we have to already set the path for our NSRL1 2.29 package. For that, type gedit space /.bashrc one notepad window is open. So ensure we have to already set this NSRL1 2.29 in 5 places, and NAM window as NS 1.11, NAM 1.11. For running our project, open the terminal window and type speedy space code, then type ns space main.tcl. This is for running our TCL files. TCL is nothing but tool command language. So updated energy for each node and each period is updating in this terminal window. So transmission between two nodes is depends only on the two nodes, so all other nodes are in sleep state. So energy consumption is reduced in our project. So the output window is open. This is called network animator window. When we click on this play forward button, it will works. This is for simulation speed. We can increase or decrease the speed. This is for simulation in time. So now the communication is start. Our process is in dynamic. So when one time, if the node 1 is created in this place, then next time it will create in another place. So our communication is done. So we use TCP communication protocol, that is transmission control protocol, and this is for center time, and this is for how many bytes are transmitted, and this circles denotes the transmission range. So this is called the beacon message. So now the transmission is done between 1, 4 and 3 nodes. So 4 is act as a relay node in this place. So purple nodes are sleep nodes. So the node which is not involved in communication is going to be sleep. So now 0 sends information, that is data packets to the node 3. When we click on this circle, what has happened is shown, that is CTS is nothing but clear to send. So now CTS message is sent at 38 bytes at a time of 15.8. Each circle have its own CTS, RTS and acknowledgement messages. For running our graph, type GNU plot space delay dot plot. So this is our delay graph, our proposed system's delay. So we have to minimize the delay of our proposed system.